Okay, so in this lesson and in the next two lessons, we're going to be talking about how to solve systems of equations. And that's what the focus of this chapter is all on, is systems in general, where a system is basically is defined in this first paragraph here. A system is a set of conditions joined by the word and. So the solution is going to be the intersection of the solution sets, meaning we're looking for what solutions do the equations or inequalities have in common. Now, for equations, for what we're going to be doing in the next three sections, there's three different ways to do this. We could do what we're doing today, which is to solve the system by graphing. We could do what we're going to be doing in the next lesson, which is solving it by substitution. Or lastly, we could use what's called the method of elimination. Now, personally, my least favorite and the least used is going to be graphing. Just because, well, each of these have their pros and cons. The benefit or the pro of using graphing as a method of finding the solution is it gives you a visual so you can see exactly where the solution is and exactly how many solutions there are. But the disadvantage is the lines don't always intersect at integers, where sometimes it's a decimal. So we're going to be doing a lot of guessing and approximating. Now, granted, for some of the problems, we'll be able to use your calculators, which is what I'll show you how to use today. But when we have to graph by hand or have to look at a graph that's been made up for us, we're going to be having to do some estimations here. Where with the other two methods we're going to learn about gives us the exact solutions. However, each of those also have their pros and cons. So let's look at the example that's already been done for us here, where this is looking at some bowling handicaps for two people. I believe the M represents the girl's name, Millie, and the N represents the boy's name, Noah. This will be referenced in your homework assignment. And you can see that as Millie's handicap is increasing, Noah's handicap is decreasing. And the solution here is where they intersect. The intersection is the point 5, 20, meaning after 5 months, they both have a handicap of 20. Now, I really want to emphasize this. Graphing, what we're doing today, is just a method. It's not the answer. If you graph something, that's just showing me your work. Finding the intersection and telling me where they intersect at is the answer. So I just want to make sure that that's clear. You're not just graphing. That's not what this section is about. It's about finding the intersection for the graphs. Now, if you were to check this, if I were to put 5 into Millie's equation here, 3 times x plus 5, 3 times 5 is 15, plus 5 sure enough gives me 20. If I were to check this in Noah's equation here, negative 5 times 5 is negative 25, plus 45 also gives me 20. So you can see that they both give me, when I put 5 in for x, they both give me a solution of 20 for y. We could also look over here at the table. The table here shows me that in month 5, they both had a handicap of 20. Now, looking at a table also isn't very good, because sometimes if we look at a table on a calculator, the answer, if the intersection is at a decimal, the table's not going to help you. So that's why we'll stick to graphing for today. So let me show you how to do this on your CAS. So what you're going to do is we're going to graph both these equations. Now, just remember, when we go to graph and you hit the home button, please do not use the scratch pad. The scratch pad is just going to cause you all sorts of problems. Don't use the scratch pad. Use this graph down here, the graph icon. Click on that. And the first equation we're graphing is y equals 1/2 x minus 5. Again, just as review, don't do anything what's to the left of the equal sign here. We never touch that. Okay, we leave that alone. But I'm going to type in 1/2 x minus 5 and hit enter. So there's our first line. Our second line is going to be 2x minus 1. Now, you might wonder, well, how can I type in a new equation here? If I start typing something, nothing shows up. You can either drag your cursor down here and click on that to show the entry line, or a fast way to do it is just hit the tab button. And now we're going to type in the equation, 2x minus 1. Hit enter. And you can see that they intersect down here. Now, right now, it's kind of hard for me to see it. So what you can do, there's a couple of options. If we want to move our paper, if you go over here and hit the control button and the center button, it's going to grab your paper. So it looks like it's grabbing a sheet. And now if you slide your finger around on the touchpad, it's going to allow us to move your graph all over the place. So once you get it to where you want it moved to, if you hit escape, that'll let go. So we want to figure out what this intersection point is. Now your calculator has this really cool feature. If you go to Menu, Analyze a Graph, and we're looking for the intersection. So now notice down here it says lower bound. It means you want to take and slide this dashed line to the left of the intersection point and then go over and hit enter on your calculator. Now notice as soon as you hit enter it changes it to say upper bound. And so now we're going to drag this to the right. Notice how already they say intersection. So just hit enter and you can see now that your intersection is at the point negative 2.67 or negative 2.7 and negative 6.3. So there's two ways you could write your answer. You could write your answer as a coordinate, or you could say x equals negative 2.7 and y equals negative 6.3. So either do it as a coordinate or say separately that x equals, like I said, negative 2.7 and y equals negative 6.3. So why don't you guys take a second and practice on your calculators. And so try graphing these two equations, y equals 3x plus 2 and y equals 2x minus 4. And pause the video and hit play when you're ready to check your answer. Okay, so let's see what you should have done. So again, to do a new screen, if you hit the home button and graph, we're going to graph our two equations. So it's going to be 1/2, I'm sorry, looking at the wrong one, 3x plus 2, and hit enter, and hit tab, and type in 2x minus 4, hit enter. Again, we can't see our graph. The other way to see more of the graph, if you're having a hard time grabbing the paper and moving it, is if you go to Menu and Zoom out. Move your magnifying glass over here to quadrant 3 and just hit enter. I'd have to hit enter a couple times. So now you can see that here's our intersection points. Now I'm going to go to Menu, Analyze a Graph. I'm going to find the intersection. Drag to the left of the intersection point, hit enter. Drag to the right of it, hit enter again. We get negative 6, negative 16 is your solution. Oops. Now let's see how we use this. Here we have Kayla is a packaging engineer at Healthy Soup Company. The marketing department has requested that she design a new soup can. The new can must hold 360 milliliters of soup and be in the shape of a cylinder. An eye-catching new label must be large enough to show the product name and all the nutritional content data. Marketing wants the area of the label to be about 225 square centimeters. What are the dimensions of this new can? And this is a problem that would be faced by a lot of different companies. For example, more recently, Red Bull, that's been out for a few years now. Red Bull wanted to separate themselves from a traditional soda, wanted to make themselves look different. So they wanted a can that would look different but hold the same amount of soda as what's in a traditional soda can. So they wanted to they knew what the volume had to be, and I'm sure the marketing department knew what they wanted what the can to look like, what they wanted the surface area of the can to be. So they wanted it, so they probably gave this problem to someone to try to figure out what the new dimensions would be, and they'd have to come up with a new radius and height that would meet the specifications for the particular volume and the surface area. Well, that's what's happening here too. So we have this volume and we have a surface area. So we're going to need two equations. One equation representing the volume of the can and one for the surface area. A volume of a can is found by taking pi times the radius squared times the height. And the surface area is found by taking 2 times pi times the radius times the height. Let's go back to the volume. The volume we know is 360 milliliters. And the only other number I know is the surface area is 225 square centimeters. So now we need to write, we're going to have to graph these, but to graph these on our calculator we need to have it in the form of y equals. Now obviously we're not going to have an x and a y here, we have an r and an h, and we'll talk about how that works with graphing here in a minute. But we want to solve one of these equations for either h or solve it for r. It doesn't matter which one we get by itself. We just want to do whichever would be easiest. Obviously, it looks like it's going to be easiest to get the h by itself, because then we don't have to mess with the square. So when you do that, we get h equals 360 divided by pi r squared. Over here, when I divide by 2 pi r to get the h by itself, I get h equals 225 divided by 2 pi r. Now when we go to graph this, your calculator does not know what an r is. It only knows x's and y's. So when we go to graph this, we need to make sure that we don't use r, we need to use x. So again, go to the home button, create a graph. So we're going to graph 360 divided by pi r squared. To do that, an easy way to do it, to make sure you get it right, hit control and divide so we get the fraction bar. And type in 360 on top, tab or arrow down to the bottom. The pi button is over here next to the h. When you hit that, this menu comes up, hit enter, and then x squared will be what goes on the bottom, and hit enter. And you should get an inverse square curve that looks like this. We talked about that back in chapter 2. So now what we want to do is we want to graph the other equation. So hit tab. Hit tab, and do control divide to get the fraction bar. We're going to put 225 on top. Arrow down or tab to the denominator and type in 2 pi times x this time instead of r, and hit enter. Now we can see that our graph is going to intersect somewhere up here in quadrant 1. It doesn't intersect down here, which really doesn't matter, because when you think about it, we're not going to have any negative dimensions. So all these other quadrants we don't care about. So if you go to menu and zoom, we have an option that says to zoom in quadrant 1, which is what I'm going to do here. So now if I zoom in quadrant 1, now I can see where my intersection point is. It's up here. So now I can go to menu, analyze a graph. We want to find the intersection. Drag to the left of those, hit enter. Drag to the right, hit enter again. And you get 3.2 and 11.2 as your solution. So as far as the context of this problem, what that means, because we don't want to write this one as a coordinate, our boss wouldn't know what that means. So we need to write it as the radius, which was our x, was 3.2. Our y was h, which is 11.2. And that would be our answer. We're not going to do this other example. We're just going to end by looking at this last topic here, that since some of the times we're not going to be dealing with straight lines, we could have situations that have more than one solution. Y equals 4x squared, that's going to be a parabola. And it's already got the y by itself, so that one's good. This one's a standard form of a line, but if I'm going to graph this on my calculator, I need to get the y by itself. So I'm going to start by subtracting 6x from both sides. Doing so results in 14 minus 6x on the right. We want to get the y by itself, so I'm going to divide by 2. Now we want to divide everything by 2. It's nice because everything's even. So when I do that, 14 divided by 2 is 7. 6 divided by 2 is 3, so it's 7 minus 3x. So I'm going to graph these two now to see where they intersect at. When I do that, again, home, make a new graph here. So we're going to type in 4x squared. Hit enter, there's our parabola. Hit tab. Now I want to do the other equation. The other equation was 7 minus, I forgot now. 7 minus 3x. It's going to be 7 minus 3x. Hit enter. Now the only problem is we only see one intersection point. But you can tell from the line and from the shape of the parabola that there's going to be more than one spot where they intersect. So we can grab the page and move it down, or menu and zoom out. So now I can see the two intersection points. Now the thing is your intersection points, and only find one at a time. So I'm going to drag this cursor to the left of my first one, hit enter, drag it to the right, hit enter again, and I can see, let me move this equation out of the way. I can see one intersection point now. Do menu, analyze graph, intersection. I want to move just to the left of my second point and hit enter, and then drag I can see my second intersection is the point 1, 4. So there you have it. So good luck on your assignment.